That was really cool. What you saw was not just how simple and quick it was to get your geospatial infrastructure up and running and ready for use, but also the fact that it's highly available production system ready. It's fully automated and designed for modern DevOps practices. There's no more guessing and hoping to get it right. As you can see in this slide, you'll notice that you can also federate your existing servers to this base ArcGIS Enterprise system to suit your needs. It's a kind of hybrid model of deployment within your enterprise. Next, I'd like to talk about scaling. Say you have a dynamic map service that's going viral. You might just want to scale that alone, and you can do that here. Now I have 3 pods running the same map service. Moving on, an Achilles heel of large enterprise systems is patching and upgrading to newer versions. Usually there's a downtime if you recreate the system. As you can see here, that's what happens when you go from one version to another. This new version that we are building is much smarter. Behind the scenes, when you apply a patch or upgrade to a new version, we apply 2 techniques to reduce downtime. The first is a rolling or ramped update, where we gradually roll the new version even as we roll out the old, like you see here. In some other cases, usually when you upgrade deeply stateful microservices like data stores, we apply a blue-green update, where we create the new and switch the load balancer to the new when it's ready. These are done automatically and helps minimize downtime on production systems. I'd like to now introduce Shreyas, who will go through 2 demos. The first is how we patch and upgrade the software, and the second is how you scale your system. It's basically automated maintenance and operations. Shreyas, please show us.
Thanks, Jay. Enterprise on Kubernetes has a new manager application that allows administrators to monitor and manage their enterprise deployments. When you log into Manager, you are taken to an overview page that gives you a broad perspective of your system, including critical logs and the status and health of important components in your system. Using Manager, you can update and configure the security settings for your organization, as well as manage software licenses. But one of the most sophisticated features of Enterprise on Kubernetes is the software update process. The system is smart enough to detect when new releases and updates are available and can alert the administrator. Let me show you how. I am at build 1250 for version 10.9. I can see that there are 2 updates that are available. Let me go ahead and install one of these updates. The update process is asynchronous and allows me to interact with the system. It's also returning detailed status messages of the update process. The process systematically iterates over all the affected microservices and in a rolling manner swaps them out with new container images. This process takes a few minutes depending upon the scope of the update. I have run an update before and it was completed successfully, and my system is ready to use. In a similar fashion, I can install the latest software release in this way. Like a modern system, this entire process can be driven with code and automation. Here I have a simple Python script that's communicating with the administrative API to look at the available version of the software, the new updates and releases that are available, and then prepares to apply the update. But before it does that, it modifies the portal user experience to notify its users with a custom banner and via email. It then prepares to apply the update and then waits for the update to finish. Once the update is done, it runs diagnostics to make sure that the health and status of the system is maintained. Enterprise on Kubernetes has been designed from ground up to aid in your automation journey, saving you valuable time and energies in maintaining your deployments. So far, we've seen deployment, configure, and maintenance of Enterprise on Kubernetes. Let's switch gears a bit and take a look at administrative workflows to monitor your GIS services. In Enterprise on Kubernetes, we've baked in the powerful metric collection server Prometheus, as well as a query visualizer Grafana into the product itself. Let me give you a quick tour of the metric capabilities. Using Grafana, I have authored a dashboard that represents the usage statistics of my simple sample world cities map service. The graph on the top left indicates the average response time for the service. The graph on the top right indicates the percentage of requests that were serviced under 1 second to meet my service level agreements. Requests are currently being generated using a simple JMeter test client. You will notice that there is some load on the server, but the system appears to be handling the requests and load well. I'm able to meet my SLAs about 100% of the times. Let's see what happens if you were to increase the load on the system. To do this, I'm going to reconfigure my JMeter test client to simulate more users. The JMeter test client is a step load tool, and it takes a few moments to ramp up. Behind the scenes, Manager communicates with the Administrative REST API. The Administrative REST API issues commands to Kubernetes to scale the pods up. When the new pods are up across your cluster, they're added to your load balancer and your service gets additional capacity. Let's take a look at our dashboard. We are now seeing that the average response times for that service are spiking. That means the system and the service is definitely under load. Our SLAs seem to be dropping as well. This is a case where an administrator like me needs to be alerted. If the load is expected, I need to provision additional capacity to handle this. As an administrator, I can do this very efficiently and effectively on a per service basis. Going back into the Enterprise Manager and access our service configuration, let's look at the settings for this service. It's currently running a single pod with some CPU and memory limits. I can either grow the pod larger by increasing the limits or increase the number of pods for that service. Let's go ahead and change this to 3. It's going to take a few seconds for the new pod and capacity to be provisioned and to have it reflected on our dashboard. Going back to our dashboard now, we can see that with the improved additional capacity, our average response times are improving. We are also able to meet our service level agreements for a higher percentage of times now. So with the increased capacity, our service seems to be doing much better without impacting our client in any way. Now I'm showing you a very manual demo, but this can be very easily automated with a little bit of scripting. Using scripts, you can query the Prometheus metrics server and collect statistics on these services. You can then feed it to a simple analytical routine that can raise an alert and take an appropriate action. In Enterprise and Kubernetes, you monitor and observe as an API, allowing you to manage and scale your geospatial infrastructure as code. Thank you.
Thanks, Shreyas. That was really cool. You saw 2 examples of change management done on a live system. We've removed the uncertainties and made it kind of mundane, you could say. That's modern CI/CD and DevOps for you, benefiting from this architecture and ensuring business continuity. ArcGIS Enterprise for Kubernetes will be released soon as part of the 10.9 release. Please check it out. What you've seen today is a small peek at the many ways you can automate your GIS, whether it's infrastructure or workflows, within your enterprise or beyond.